the next question. The marks obtained in mathematics by 1000 students is normally distributed with mean 78% and SD 11%. Determine how many students got marks above 90%. Second question. What was the highest mark obtained by the lowest 10% of the students? Third one. Within what limits did the middle of 90% of the student lie? Now in this question we have mean as 78% and that is converting into decimal as 0.78. Next SD as 11%, that is sigma is 0.11. The first question, how many students got marks above 90%? So x is equal to 90%. So percentage always convert into decimal. So this 90% is 0.9. Then what is the z value? So z is equal to the formula x minus mu by sigma, and that is equal to 0.9 minus 0.78 by 0.11. So the value is 1.09. So probability of x greater than 0.9 is equal to probability of z greater than 1.09. So you are finding this area 1.09 above part. So this is 1.09 above part, that is shaded part, should be found. As you know, half of this normal curve is 0.5, and from 0 to 1.09 the area is 0.3621 from the table values. So by subtracting these two you will get the shaded part 0.1379. So this is the probability of x greater than 0.9, that is above 90%. So you have to get how many number of students. So number of students are given as 1000. So 1000 into this above 90% marks is equal to the students count as 138. Now coming to the second question. What was the highest mark obtained by the least 10% of the students? So least 10% of the students means the area to the left of z. So this is z value. So the area to the left of z. So 10% is 0.1. So that is least one. So you have to select this part. So this part is 0.1. So whenever this part is 0.1, the remaining how much should be there to get to this total half area as 0.5? So you have here this part as 0.4. Now if you know this area, can you find this z value? Yes. How we can find? According to the table values. So in the middle you will have everything as the area. So these are all middle values, all everything areas. So according to this area you can get the z values. So what the z value we got here? Minus 1.29. Why have taken this minus? Why? Because we have the least 10% of the students. So this least part is this side only, negative value. That's why z1 is equal to minus 1.29. Next, that z1 value, if you substitute in this standard normal variate, you get the x1 value as 0.6392. But finally what should we get? The highest mark obtained by the lowest 10% of students. So number of students are 1000. So it's 1000 into who got this lowest 10%? 0.6392. Multiplying these two, you get the mark, highest mark as 64. This is the second question. Next, what is the third question? Within what limits did the middle of 90% of the students lie? So you have to find the limits of that marks. So middle 90%, that is corresponding to 0.9 area. So 0.9% of the area is here. So 0.45. So how we'll get 0.45? 0.9% of that area is 0.45. So if you got this one as 0.45, the remaining part will be 0.05. Why? Because this half part of the normal curve is 0.5, symmetrical part. So this is 0.5 and this one is also 0.5. Now the area from 0 to this z is 0.45. So you can find this z value from the table values. How much we get here? 1.65. Actually this we have to take plus or minus. Why? Because if you take this side, no, you will get here 0.45. if you take this side also, you will get here 0.45. so symmetrical cases, that's why I have taken z value as plus or minus 1.65. So by substituting in the standard normal variate, first negative value minus 1.65 is equal to x1 minus 0.78 by 0.11. Then you will get x1 as 59.85%. Next, if you take positive 1.65 in the same substitution, you will get x2 as 96.15%. That means the middle 90% have the marks in between this 59.85 to 96.15%. That means you can write simply 60% to 96%. That's all about this probability distribution. In the next video, we continue the fourth unit